There are three log rules that I'm going to be discussing in this video. The first one is called the product rule. The product rule just says that log to the base b of x times y is equal to log to the base b of x plus log to the base b of y. So, for example, let's just say I had log to the base 10 of 4 times 2. That would be equal to log to the base 10 of 4 plus log to the base 10 of 2. The next rule is the quotient rule, and the quotient rule just says that log to the base b of x divided by y is equal to log to the base b of x minus log to the base b of y. So note, when we have multiplication, we could break it up into an addition problem. When we have division, we can break it up into a subtraction problem. So for example, I'll just use the same numbers. Let's say we have log to the base 10 of 4 divided by 2. That can be broken down into log to the base 10 of 4 minus log to the base 10 of 2. And the third rule is called the power rule. Now the power rule says that if you have log to the base b of x to the y power, that's going to be equal to y times log to the base b of x. So really what you're doing is you're just taking this exponent right here and you're bringing it to the front of the word log. So if I had log to the base b of 4 squared, even if the 2 is on the outside of the parentheses, I can take that 2 and bring it to the front of the word log to leave me with 2 times log to the base b of 4. One thing I just want to quickly point out is that these rules only work when the base is the same. Okay, so let's try out some examples. The directions say to expand the following log expressions. So in number 1, we have log to the base 3 of 2 times x. So here we can use the product rule. Now the product rule tells us that we can expand this into the sum of 2 separate log terms. So we can rewrite this as log to the base 3 of 2 plus log to the base 3 of x. Number 2, we're going to use the quotient rule because we have 16 divided by m. Now the quotient rule tells us that we can take this expression and break it up into the difference of 2 log terms. So we can rewrite this as log to the base 4 of 16. And if you don't want to put parentheses, if you just want to write it like that, that's okay. Minus log to the base 4 of m. And then finally, number 3 asks us really to use the power rule here because we have x to the 3rd power. So we can take this power and bring it to the front of the word log. So we can rewrite this as 3 times log to the base 10 of x. And again, if you want to put parentheses around the x, you can. If you don't want to, you don't have to. All right, so let's take a look at some examples that incorporate all of the rules that we learned about today. So in number 4, first thing you could see is we have the 8x to the 4th being divided by the 5. So if we want to take this log expression and expand it, we can first separate it into 2 log expressions separated by a subtraction sign because of our division here. So we could first rewrite this as log to the base 2 of 8x to the 4th minus log to the base 2 of 5. Okay, now, if we look within our parenthesis here, we have 8 times x to the 4th. So multiplication tells us that we can take this expression and separate it into the sum of 2 log expressions. So instead of having log to the base 2 of 8 times x to the 4th, we could have log to the base 2 of 8 plus log to the base 2 of x to the 4th. And then I'm just going to take this minus log to the base 2 of 5 and just bring it down. Okay, and then finally, The power rule tells us that we're going to take our exponent here, the 4, and we're going to bring it to the front of the word log. So I'm just going to bring down my log to the base 2 of 8. Again, I'm going to move this 4 in front of the word log, so it'll become 4 times log to the base 2 of x. And then I'm going to bring down my minus log to the base 2 of 5. Oop, this is supposed to have a little base 2 right there. In number 5, you'll notice that there is a radical above the y. We have the square root of y here. Now what you want to first do is you want to rewrite everything so it has exponents. So we know that the square root of y is equal to y to the 1/2 power. So let's just rewrite this as log to the base 2 of x squared times y to the 1/2 power over z to the 4th. Okay, so if you have radicals, just make sure you first change them into exponents. Okay, so now from here, we have the x squared y to the 1/2 being divided by z to the 4th. So again, we can start this off the same way we started off number 4. We can break this up into 2 separate log expressions separated by a subtraction sign. So we'll have log to the base 2 of x squared y to the 1/2 minus log to the base 2 of z to the 4th. Because again, division allows us to break it up into 2 separate log expressions separated by a subtraction sign. Now, if we look within our first parenthesis here, it's x squared times y to the 1/2. So the product rule tells us that we can break up multiplication into 2 separate log expressions separated by an addition sign. So we'll break that up into log to the base 2 of x squared plus log to the base 2 of y to the 1/2 power minus log to the base 2 of z to the 4th. All right, and then finally, the power rule tells us that we can take each of these exponents here, so this 2, this 1/2, and this 4, and just bring them to the front of the individual log term that they're connected to. So if I bring this to the front, we'll have 2 log to the base 2 of x plus 1/2 log to the base 2 of y minus 4 log to the base 2 of z.